Okay, so first off, we're in a new section on confidence intervals. So I want to have a little summary real quick on confidence intervals. Up to this point, we've been dealing with proportions. Okay, and that's when we had the p hat plus or minus z square root p hat 1 minus p hat over n. Okay, that's what we've been dealing with. So we're going to introduce a new concept here, and we're going to be dealing with means. Averages, means. So we're going to deal with x bar, not p hat, x bar, average, plus or minus a new thing, the t-score, and then we're going to have s, and not an 8, I'm going to do an 8, times s over the square root of n. Now this s is the sample standard deviation. Not the standard deviation of the population, the standard deviation of the sample. And we're going to see actually that it's very rare to get the population standard deviation. So we're going to be dealing with that. It's x bar plus or minus t. That's just a little star, this is symbols used, times s, the sample standard deviation, over the square root of the number of participants or whatever. All right. So in this activity, we're going to investigate the problem caused by replacing sigma. This is the sigma symbol, that funky symbol we're using. Now remember, this symbol we've been talking about for a while is the population standard deviation. And we're going to be replacing the population with Sx, which is the sample standard deviation. That's the S that we just talked about in the formula. Okay, we calculate confidence interval for EU and how to fix it. All right, so a farmer wants to estimate the mean weight in grams of all the tomatoes on his farm. To do so, he will select a random sample of 4 tomatoes. Now, 4 tomatoes is definitely not satisfaction for the large numbers. It's not greater than 30. So hopefully it's going to be normally distributed. He wants to calculate the mean weight and use the sample mean to create a 99% confidence interval for the population mean. Suppose that the weights of all tomatoes on this farm are approximately normal. Yay. So right off the bat, that tells us we're okay. Even though we don't have large numbers, we don't have more than 30, it's approximately normal. Now there's a mean of 100 and a standard deviation of 40. Okay? So we're going to use this applet. Now you don't have to mess with this. I'm just going to model it for you and show you how this works. Okay? So bring this up and play with the numbers. Now, we've been dealing with proportions. We're going to change this to means. All right? And we're going to keep it with the sigma for right now. And we have that for 1. This needs to be 100. Because that was the mean. Our standard deviation here was 40, and our n was only 4. Okay, so we're going to, and we wanted a 99% confidence level. So, this right here is our mean. Whoops. I lost my thing. Oh, because I'm not on the board. Right. So you can see the 100. That's our mean. Does our confidence interval, the green line, does our mean fall within the green line? Yes, it does. Okay? So I'm going to hit it a few more times, see what happens. So I'm doing it over and over, and each time what's happening? it is included in, now sometimes it's pretty close, but it's been included every time. Okay? So now I'm going to change the intervals to 100. Okay? And see what happens. Whoops. Did not mean to do that. I hit the wrong thing. Gotta do it all over again, yes. Sample. Oops. What did I miss? Oh. Oh, means. Okay, it's making me do it again. Let's try this one more time. 100, 40, 4, 99. Where is this? Okay, so as you can tell looking at this, okay, almost all of ours fell within, except for how many? A few outliers. One, the red one. Purple, whatever you want to call it. Whatever this color is, it's not green. Okay? That confidence interval does not include the mean. So if you look at the running total down here, which doesn't show up on the screen, the running total says 99 out of 100. So 99 times out of 100, it did include our amount. That's a pretty good amount. Okay, so we did all that. How well did method 1 work? Compare the running total in the lower left corner with the confidence interval of 99%. Well, we actually got 99%. But let's go back and say if we only did it the one time, what would happen? So we're going to recalculate it. I'm going to change this to 1. Okay, so I'm going to start it there. And like I said, we're still getting it at 100%. So it was interesting in the previous class. It actually was 90. What was it? 97.5. So the running total was more in the previous class. This time we end up with 99%. Again, we got some randomness there. All right, so now method 2. Okay, because we're not always going to have the population. Okay, so for method 2, we're going to do this again, except this time we're going to do Z with S, the sample population. And I'm going to run my sample. And it falls within, falls within. Oh, there was one that didn't hit. There's another one. Gonna do a few times. So right now we're at 16 out of 18. 88.9. Let's change this to 100 and see what happens. Okay. So look how many more we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So look at our running total there. 90.7. So, was method 2 as good as method 1? No. Not as accurate. And we ended up with 93, down here, I put that in the wrong thing. That goes to number 3, and this should have been 93 point, what was it again? 90 point something? 90.7, way lower. Okay? Now, it says to increase the capture rate of the intervals to 99%, we need to make the intervals longer. So we're going to do this by using a different critical value called a T critical value. Not Z-score, but a T critical value. We're going to learn how to calculate it later. Right now, we're just going to learn how to use it. So I'm going to start to do one more time. and see what happens. So look how the intervals are longer, right? So now I'm going to change it to 100, see what happens. Okay, so we have 2 there. Oh, 3, you're right, 3. 3 that didn't make it. Now, to method 1, we actually got kind of a freak answer of 99% of that first one. So I'm going to say, not this time, but should have been slightly better. But we actually ended up with, we'll do it again, 98.6, no fever. But pretty close to 99. But that 99 on the first one was a little bit high. We just kind of got a random number that was really high. But we ended up 98.6 on this one. So in this case, we're going to be using this because in case 1, we knew the population standard deviation. We're not normally going to do it. So the real important comparison here is the 98.6 compared to the 90.7. Using the T critical value is going to be much better for what we're doing for the rest of this. All right, so we're going to put my screen on. So we use T critical value over Z critical value when we use the sample standard deviation. Okay, so since we don't have the population, we're going to use T. It's very rare that we'll have the population. Actually, it's very, very rare you'll see. Now, using table B. So everybody, you look at your packets. We're looking at table B, which is a 1-pager. So on table B, we're going to find the correct confidence level at the bottom of the table. Okay? So if you notice, down here is where you're going to look. Yes, there are numbers up here, but that's not what we're looking at. We're looking at the bottom. So 95%, 98%, and so forth. That's what we're looking at. We'll come back to that in a minute. On the left side, you'll see the DF. Okay? That stands for degrees of freedom. For this interval, DF is always n minus 1. So whatever your sample is, you're going to subtract 1 from it. Don't worry about why. It's a long, complicated, boring reason. But it's just n minus 1. In the body of the table, you find the values of the T corresponding to the confidence level and DF. So in other words, it's the intersection of the degrees of freedom and the confidence interval. Now, if you notice, look at your chart. It goes 1 to 30. But after that, it jumps to 40, 50, 60. Then it jumps to 80. Then 100. Then 1,000. So at any point, your number is not on here. Your degrees of freedom aren't on here. You're actually going to slide backwards to the previous number. So if we had 35, we would slide back to 30. If we had 59, we'd slide back to 50. 79, we go all the way back to 60. If we had 389, we go all the way back to 100. Okay, so that's how that's going to work. Now, this is easy, and this is all we're going to do, and this is all the homework's going to be. So, 99% confidence interval with an n of 4. So what is my degrees of freedom on an n of 4? Really tough, n minus 1. 3. Wow. Okay, so the DF is going to be 3. So we look at 99% which is right here. And we're going to go up to where it intersects with 3. 5.841. Okay, so what we're doing is we're looking at 99%, and we're going up to see where it intersects with 3. Okay? Next one. I'm not going to go back and forth. We're going to look at 95%, which is right here. And we're looking for a DF of what? If the n is 20, what's the DF going to be? 19. So we look at 19 and 95%. And that's going to be 2.093 with the degrees of freedom of 19. Now this one's a little tricky. What's the degrees of freedom on this one? 47. Is 47 on the chart? No. It is not. So we have to go slide back to what? 40. Very good. So we're going to look at confidence interval of 98, which is right here, and we're going to go up to 40. 2.423. 2.423. All right. Now, your homework. Here's your assignment, number 5. All right, so I'm going to write down critical information and then transfer it over. So for 5A, we have 95% confidence interval and n equals 10. For 5B, it's 90% confidence interval and 77. So, for 5A, 95%, n equals 10. What's our degrees of freedom for that? 9. So, if you look at the chart, what is 95% with a degrees of freedom of 9? 2.262 is correct. For 5B, it's going to be 90% and n of 77. So what's the degrees of freedom there? 76. What number are we going to slide back to? 60. And that's going to yield what for T? 1.671.